Hello everyone and welcome back. So in this lecture we are going to go ahead and look at an example of server-side request forgery in our sample application, and as I mentioned we are going to focus on the put route for our users where we are updating a user information using the user ID. Now in this route we are taking the user ID as path parameter in our URL, and then we are doing an authentication check. Some validate object ID middleware is also there. Let's look at this function. Now here we are just checking that the object ID or the user ID that is being passed as path parameter is a valid Mongoose object ID type, right? That's the only check we are doing here. And then so we are just finding the user by its ID from user collection. Now if we go back to a user interface and log in with user 1, let's say, or let's log in with our new user, user 6, right? Now here if you go to user's profile page and try to edit the user, it gives us some of the options to update the user here. So let's say I update it as the name as Ankur, email I'm going to keep the same. Now here I can also update the website, or it's giving me an option to update the URL of the user. Now here I can put anything, let's say user6.com. Now it's asking me to update the password. I can do that here and then click on edit. My user is successfully updated. Now look at the network call. So here we are hitting the API users/user ID as path parameter. This is the put request, and in payload I'm sending all these details, right? And one of these is the URL. So it's giving us an option to pass URL here. Now let's go back to our code. Now in this code there is a potential server-side request forgery or SSRF vulnerability that can be exploited by modifying the request body.url parameter. So we are passing the URL here in the put request. Let's analyze how an attacker could exploit this vulnerability step by step, right? Now the attacker sends a put request to the server targeting the /ID endpoint here. The next step, attacker modifies the request.body URL parameter by injecting malicious URL, right? Instead of injecting users website or any other not harmful website URL, it can be a malicious URL, right? Something like the one we saw for AWS scenario, where attacker can send the VMs or EC2's metadata URL and get back security credentials. So here also attacker can pass in a malicious URL. It could be an organization's internally hosted URL, right, to which the host or the VM where your application is running has access to, right, because it's an internal network. So it's quite possible that your VM where the application is running, right, your Express API has access to that other hosted API endpoint or that URL endpoint. Now the server uses this needle library here, right, to make a GET request to this URL. The attacker's modified URL or the internal resource URL triggers the SSRF vulnerability. So the server makes a request to the specified URL, potentially accessing internal resources that should not be exposed publicly, right? In this case, the server retrieves a response body from malicious URL and stores it in the domain variable, this one, once the request is successful. After making the external request, the server continues with the request handling. It hashes the request body dot new password parameter and then updates the user's password. Finally, the server updates the user information, including the potentially exploited request.body.url parameter in the MongoDB collection. So this is how the attacker has successfully manipulated a server-side request to access internal or restricted resources, potentially exposing sensitive information or performing unauthorized actions. And not to mention, in the end, we are also sending back the domain information here, right? So anything that comes back from this malicious URL call to internal resources will go straight to the attacker as response to this put request. Now to mitigate this vulnerability on the server side, there are a lot of different steps that you can take, right? You could do server-side input validation, and whitelisting should be implemented to ensure that your request.body.url parameter can only access safe and trusted URLs. Additionally, in case if your server needs to make requests to external resources based on user input, again in this case you should maintain a allow list of URLs that should be checked before making the request. Take other steps that you can take is isolate the resource fetching mechanism to retrieve remote resources which are not internal ones. Also keep a allow list of all the ports, URL schemas and accepted file or media types. Disable all HTTP redirections. Validate and sanitize all client supplied input data. So everything that comes in as request body, path parameter or query parameter should be validated and sanitized before further processing them. And then of course avoid sending raw responses to clients. So this was all about server side request forgery in our sample application and in general, and the steps you can take to mitigate it. That's all for this lecture, and I will see you in the next one with a new vulnerability. Thank you.